We have this incredible AI now. It can write code, it can browse the web, talk to all sorts of complex APIs.
Yeah, theoretically, it seems like it can do almost anything.
But then you give it a real job. Maybe something involving, say, 20 different tools to run a marketing campaign.
And it just falls apart, often spectacularly.
Right. It's this weird paradox we're seeing in automation.
Totally. It's like you hired one intern, super eager but totally overwhelmed, to do the jobs of 20 different experts.
And you end up just babysitting it, fixing errors constantly. There's zero reliability there.
Exactly. And what our sources are digging into this week shows the solution isn't just making the AI model itself smarter.
No, it seems the breakthrough, especially looking at Claude Code's new sub-agents feature, is really about a smarter organization, a better architecture.
Welcome to the deep dive. Our mission today really is to give you the knowledge to shift your own role. We want you to stop being just a prompt engineer, constantly wrestling with one big confused agent.
And start acting more like an AI manager, overseeing a team.
That's the goal. So we'll unpack why those single do-it-all super agents tend to fail.
We'll get into the details of this new manager specialist architecture.
Yeah, and we'll look at a pretty cool live demo of an AI CMO that achieves some amazing speed.
And finally, touch on the huge economic advantage this kind of scaling offers.
All right, let's dive in. Where do we start? The fundamental problem.
Yeah, let's start there. The super agent flaw. Okay, so let's unpack this a bit. The first big structural problem, according to the research, is something called the tool overwhelm problem.
Right, and it's totally counterintuitive, isn't it? You'd think more tools, more power, better results.
Exactly. Given more capabilities, it should be smarter.
But it actually seems to work the other way around for these single monolithic AI agents. Give it, say, 5 really crucial tools: Twitter, search, image generation, maybe data analysis, a database connection. Even then, its performance gets kind of shaky.
And if you push it to 20 tools?
Oh, it's chaos. Imagine equipping a race car driver, but cluttering the entire dashboard with 20 different emergency tools.
Yeah.
They spend the whole race just trying to figure out, okay, which wrench do I need now? Which button? Is this tool even relevant?
The agent's focus just fragments.
Completely. Accuracy just tanks. It becomes this confused, totally unreliable mess.
And it's crucial to understand this isn't because the underlying AI model isn't intelligent enough.
No, not at all. It's the design itself. That single agent architecture, it's just fundamentally flawed for this kind of multi-tool complexity.
And that internal confusion, that chaos, it directly messes with the AI's short-term memory, right?
Yeah.
What they call the context window.
Exactly. Think of the context window as the AI's active workspace. It's RAM, basically.
Okay.
Now, imagine cramming instructions for all 20 tools, plus examples for each, plus the entire conversation history, all into that one limited space.
You get what the source calls context window pollution?
Precisely. You're forcing the poor AI to wade through this huge, messy pile of information just to find the one instruction it needs for the immediate task.
It's like trying to have a focused chat while 50 different instruction manuals are being read out loud right next to you.
Yeah, exactly. That kind of noise just kills performance, kills consistency.
And then naturally, when something goes wrong inside this big tangled agent, debugging it sounds like a complete nightmare.
Oh, it is. It's almost impossible to figure out why something failed. Did that Twitter post bomb because of an API key issue?
Or was the image format wrong? Or did the agent just get confused about the instructions?
Right. Everything's tangled up. You can't isolate the problem. You can't test individual parts reliably.
So these single agents, they fundamentally don't scale well. Every time you try to add a new capability, you risk breaking something else.
It's this vicious cycle of adding features and reducing reliability.
So if you had to pick the single most frustrating flaw of these monolithic agents,
ultimately, it's their unreliability and the near impossibility of debugging them efficiently. They just become untrustworthy.
Okay, so if the biggest flaw is that unreliability, that tangled mess,
yeah,
we need an architecture that fundamentally isolates failure points.
Exactly. And that brings us to the breakthrough idea behind the sub-agent model.
Right.
If we stop thinking of the AI as one giant brain trying to do everything and start thinking about it more like an organization, like a company, the solution becomes kind of obvious.
You need structure, hierarchy.
Yes. A hierarchy that mirrors how effective human teams work. You move away from that one confused generalist.
Towards a manager leading a team of specialized workers.
Precisely. We're talking two distinct layers here.
Okay.
At the very top, you have the master agent. Think of this as the CEO, the project manager, the manager. This is the only agent the user actually interacts with.
So its job isn't doing the work itself.
No, its job is pure delegation and strategy. It takes the user's big, high-level requests.
Like run a marketing campaign.
Yeah, and breaks it down into smaller, specific tasks for the specialists. Crucially, it operates at the planning level, not the tactical doing level.
Okay, but wait. Isn't there a risk we've just moved the complexity? Like, instead of me managing 20 tools, now I'm managing a master agent who has to manage, say, 3 specialists. What if that master agent messes up the delegation? Isn't that just a new, maybe even bigger failure point?
That's a really sharp question, and it's valid. But the key difference is the kind of instructions the manager needs.
So,
The manager doesn't need to understand the nitty-gritty details of the X API, for example. It doesn't need the technical manual.
it just needs to know.
It just needs to know what the X specialist can do, when it makes sense to call that specialist, and what kind of information needs to go in, and what kind of result comes out, inputs and outputs.
Oh, okay. That level of abstraction is really powerful then.
Yeah.
It lets the manager focus purely on the high-level plan, the orchestration.
Exactly. And then beneath the manager, you have the sub-agent layer. These are the specialists.
The workers.
Right. Focused AI assistants. The web research specialist. It only has web search tools and instructions about doing good research.
The image generator only knows about image generation APIs.
Precisely. And this is what gives you that crucial benefit. Isolation and reliability.
Ah, I see.
Each sub-agent has its own clean, isolated context window, its own little workspace focused only on its job.
So if the X poster agent fails, maybe the API key expired or something.
You know exactly where the problem is. It doesn't mess up the image generator or the researcher. It doesn't derail the master agent's entire plan. You can debug that one specialist in isolation.
That makes sense.
Yeah.
And the delegation flow, you mentioned speed.
Yeah, this is key. You give the master agent that high-level command, create a social media post about the new feature.
Right.
The manager figures out the steps. Okay, need research on benefits, need an image, need tweet text, need to post it. Then it delegates those tasks.
And crucially, it can delegate them at the same time.
Right.
This isn't necessarily step 1, then step 2.
Exactly. That's the parallel execution advantage. This is where it gets really interesting.
Okay.
These tasks don't have to happen in some slow, lineal sequence. The research agent can be bigging up info while the image agent is generating visuals, while maybe another agent is analyzing some data. They can work concurrently.
Wow, okay. That obviously speeds things up dramatically for complex jobs.
Hugely. It's the difference between a slow assembly line and, like, a synchronized team working together all at once.
So going back to the context problem, how does delegation fix that?
It fixes it because each specialist has its own clean, isolated memory, focused only on its specific task. No pollution. Okay, to make this really concrete for you, the sources walk through building an AI chief marketing officer, a CMO.
Right, this is the demo example.
Yeah, this master agent, the CMO, manages a small team, just 3 specialized sub-agents, but they're powerful together.
Okay, who were they again? There was Agent 1, the web researcher.
Yep. Often color-coded cyan in the docs. It uses tools like Brave Search, Firecrawl, stuff like that for pulling information.
Then Agent 2, the X API poster, coded blue. Its only job is posting to X using their V2 API.
Right, very focused. And Agent 3, the image video generator, or green. This one calls out to something like the FAL API to use models like Flux or Stable Diffusion for visuals.
And the core instructions, the brain of the operation, is the master agent's file, Claude.md.
Exactly. That file defines the CMO's philosophy. Delegate strategically, execute in parallel, synthesize the results for quality.
What really struck me here was how accessible the setup seems technically. You're not writing complex Python code necessarily.
Not for the core architecture, no. You're mainly creating structured markdown files. You define the agents, list their single tool, give them focused instructions.
Yeah, the structure seems pretty logical. You got a main.claude directory, inside that an agents folder where the specialist markdown files live.
Yep. And then the main Claude.md for the master agent's instructions right there.
And critically, that separate security file, sensitivekeys.md.
Oh yeah, that's super important.
Anyone who's ever accidentally pushed an API key to a public GitHub repo knows that, like, cold dread feeling.
Huh, been there.
This architecture forces you to put those keys in sensitivekeys.md, and it's set up to be ignored by version control, like Git. It builds in good security practice.
Definitely a smart move. Okay, so now for the big test of this AI CMO system, the command they gave it was pretty complex.
Yeah, what was it? Generate an image.
Generate an image of a space panda. Then compose a compelling, short, like 2-sentence tweet about the power of delegation.
Okay.
And then post both the image and the text together on Twitter.
Right, so that's not just one simple API call. That's multiple steps, some needing to happen in order, some maybe in parallel.
Exactly. The master agent has to plan it out. Okay, step 1, delegate image generation to Green.
Green agent makes the space panda.
Right. Then Green reports back, done, here's the image. Master agent then thinks, okay, now I need the tweet text. It composes that itself based on the goal.
Synthesizing the request?
Yep. Then step 3, delegate posting to Blue, give it the text in the image file. Blue agent handles the Twitter API call.
And the reliability comes from that isolation we talked about. If Blue fails, it doesn't break Green.
Exactly. But the speed, this is the kicker. The total time from giving the command to the tweet being live with the image.
How long?
About 15 seconds.
15 seconds. For that whole workflow, that is staggering.
Right.
I mean, I remember trying to manually chain API calls like that. Latency issues, error handling, that could easily take the better part of an hour with constant human checks. This completely changes the ROI calculation.
It really does.
Cool. I mean, just imagine scaling that.
Yeah.
1 billion queries like that.
Yeah.
Handled in seconds, reliably, because each part is isolated.
That's the potential. So the biggest takeaway from that CMO test.
Reliability and speed are unlocked through that architectural isolation and coordinated delegation. It's the structure. Welcome back. So we've established this team. Architecture is really powerful, technically speaking. But let's shift gears a bit and look at the economics. Because this approach seems to fundamentally change how we think about scaling work.
Absolutely. Think about traditional scaling with humans. It's inherently linear, right?
Right. Slow, expensive.
Very expensive. If you have a workflow that needs, say, 5 people, you have to find them, hire them, train them, pay salaries, benefits. You're easily looking at $500,000 or more annually. And it takes time.
But scaling with these AI agents,
yeah,
it's different. It feels exponential.
it is. Once you've perfected that automated workflow, that agent team, you can essentially duplicate it instantly.
Right. Spin up another instance.
Exactly. With perfectly consistent quality running 24/7 for minimal extra cost, basically just compute costs.
The time you invest upfront in building and refining that agent team, it has compounding returns. It just keeps producing value day in, day out, without getting tired or needing a coffee break.
And critically, think about the risk with human scaling. You've got HR issues, communication breakdowns, sick days, quality variation between people.
Yeah, the variability.
AI scaling, when done right with this architecture, largely eliminates that variability. The output is predictable. That predictability itself is a huge strategic asset beyond just cost savings.
The sources actually provide a helpful way to think about when to use which type of AI system, like a little decision guide.
Yeah, it breaks down nicely. First, you've got the basic single agent, the Swiss Army knife.
Good analogy.
It's great for simple stuff, exploratory tasks, maybe drafting an email, doing a quick search query, your first pass at something.
But as we discussed, the moment you try to load it up with too many tools, more than, say, 5 to 7.
The blade gets dull fast. Reliability just plummets because of that context window pollution. So it's really only for low-stakes experiments or very simple tasks.
Okay, then there's Claude projects. The analogy there was a shared office.
Right. Think of this as designed for human teams collaborating with AI. It's about shared knowledge, like maybe a company style guide or project data files that everyone on the team, human or AI, needs constant access to.
So that context is always loaded.
Yeah, it's loaded all the time for everyone working within that project space. Good for collaboration and shared understanding.
Which brings us back to the subagents, the specialist team.
This is the heavy-duty option. This is what you use when you need complex, multi-step workflows to run autonomously and reliably.
Like managing a real-time inventory system or running a complex multi-channel marketing automation stack. Things where failure is costly.
Exactly, where reliability is absolutely non-negotiable.
But it's not magic, right? Getting that master agent's instructions correct still requires effort.
Oh, definitely. And I'll admit, I still wrestle with prompt drift myself sometimes when I'm trying to really nail down the precise delegation logic for a complex manager agent. Yeah, getting that initial instruction set just right, making sure it anticipates edge cases. It demands real precision up front. But the payoff in reliability and autonomy is huge.
And the sources mentioned a really powerful idea.
Yeah.
Combining these approaches.
Yes. That's the most sophisticated setup. Imagine you use a project as the shared workspace, holding common knowledge.
Okay.
Inside that project, you have a master agent acting as the manager
Hmm.
who delegates specific tasks to various sub-agents, the specialists.
Right.
And maybe one of those specialists needs to call a custom API. You've built like your company's proprietary pricing engine or something.
Wow. Okay. So you're layering these different structures together.
Exactly. Building a truly integrated intelligence system.
So just to circle back, when is that simple single agent Swiss Army knife still the better choice?
It's best for initial learning, doing simple one-off tasks, or just experimenting where the stakes are low and occasional failure is acceptable. Looking back, the speed of evolution in AI capabilities is just wild.
It really is.
Yeah.
Think about it. 2022 was largely the chatbot era, right? AI could write impressive text, but it couldn't really do much in the real world.
Yeah, couldn't take action. Then 2023 became the tool user era. Agents could start using APIs, browsing the web.
But as we've discussed, they were often unreliable when juggling too many tools. Lots of cool demos,
Yeah.
but hard to put into serious production.
Exactly. And now, here in 2024, we seem to be entering the team era. It's this multi-agent coordination, the sub-agent architecture.
That's the leap that finally seems to be solving the reliability problem.
Yes, this is what's making autonomous AI robust enough to move out of the cool demo sandbox and into actual, dependable production systems.
And this team architecture, it starts to feel, well, the source uses the term AGI adjacent, not conscious AI, but demonstrating capabilities that feel closer to general intelligence.
Right, it's about the capability, not sentience. And it shows several key properties.
Like goal-directed behavior, this is a big one.
Huge. You don't have to meticulously script out step 1, step 2, step 3 anymore.
You give the master agent a high-level goal. Launch a social media campaign for product X.
And it figures out the necessary subtasks, the dependencies, who needs to do what, in what order. It decomposes the goal autonomously.
That's pretty powerful. It also shows planning and adaptation, right?
Yes. And this is absolutely key for reliability. What happens if, say, the image agent fails? Maybe the prompt was ambiguous, or the image service had a temporary outage.
In the old model, the whole process might just crash.
Right. But a well-designed master agent doesn't just give up. It looks at the overall goal, get a relevant image for the campaign, and it adapts the plan.
So it might pivot. Maybe it calls the web research specialist instead, asks it to find a suitable stock photo that fits the theme.
Exactly. Or it might just try reprompting the image generator with a simpler request. That ability to analyze a failure in one part of the system and dynamically change the plan, that sophisticated, high-level organization, that's adaptation.
And that capability allows these systems to run really complex multi-step jobs on their own for potentially hours without needing a human to step in.
That's the goal. That level of persistent, reliable, autonomous operation is what unlocks the next huge wave of automation potential.
So what truly makes this step, this move towards a team architecture, so significant?
It solves the critical reliability problem that really kept AI agents stuck in that interesting prototype phase for so long.
Okay, so if we boil down everything we've discussed, the key lesson seems crystal clear. We need to stop trying to build one single monolithic AI brain that's supposed to be smart enough to do absolutely everything.
Yeah, that path seems to inevitably lead to complexity, confusion, and unreliability.
The future, at least for reliable autonomous AI, seems to be about building systems that function more like effective human organizations.
Exactly. You need a strategic manager overseeing a team of hyper-focused specialists who collaborate effectively.
And it's that coordination, that structured delegation and isolation that finally cracks the reliability problem. It makes these complex AI workflows genuinely production-ready today.
This architecture gives you, the builder, incredible leverage. You're shifting your role. You're no longer just coding a script. You're potentially the manager of a full digital staff.
A staff that can operate 24/7, perfectly consistently, without needing HR departments or worrying about burnout.
So we want to leave you with a final kind of provocative thought to mull over.
Okay.
Think about your own work or your team's work. What's a complex, human-sized workflow, something that currently takes maybe weeks of back and forth sequential effort and a constant oversight? Could you replace that entire process with a coordinated AI agent army built on this architecture that executes the whole thing reliably in mere seconds?
It's a powerful question. Where should someone start if they want to explore this?
Start small. Don't try to build the whole army at once. Pick one single tool, one API your workflow depends on. Build a dedicated subagent just for that one tool. Test it thoroughly in isolation. Get it working reliably.
And maybe add a simple master agent to manage just that one specialist.
Exactly. Expand gradually. Add another specialist. Refine the manager's delegation logic. The future of work is shifting, and it's ready for you to start building it piece by piece.
Great advice. Dive deeper. Experiment.
And we'll see you next time.